today we will be going over how to navigate word problems where we're utilizing a normal distribution. So we have a word problem here that essentially goes over, it says the height of adult women are normally distributed, which is something that's relevant, with a mean of 63 inches and a standard deviation of 2.5 inches. Okay, so off top, we know that we're working with a formula that's going to only be utilizing relevant for a normal distribution. We then further go a little bit down lower. We're going to solve for both these at the same time. And it says if 36 women, so 36 women, that's our sample size, are randomly selected, what's the probability that the mean height is less than 62 inches? Okay. And then it says here, if 70 women are taken as samples, what's the probability that the mean height is greater than 62.5 inches? So everything's different here, but we have a sample size and we have a direction. So based on this, we definitely are going to be dealing with a z-test. So we're doing z equals the probability of sample mean minus population mean. And by the way, I'm definitely utilizing the equation function, so you will not see this until after I'm done, divided by the square root of the sample size. So this is the relevant formulas of what we're going to be using today. Then it says to state your given. So we already know that the mean, or the population mean, is 63. So we can do mu equals 63. Okay. And then it says the population standard deviation is 2.5. So we're going to do the population standard deviation. That's sigma. It's 2.5. We have two sample sizes. The first one is 36 and the second one is 70. And so for the first equation, we essentially will be doing the probability of x being less than 62 inches. And I'll put that up here. I'm going to put that here and you'll see why in a bit. And then the second one is greater than 62.5 inches. So the probability of x being greater than 62.5 inches. Okay. So we pretty much have two of them. We'll put this one up here and we'll put this one here. Okay. All right. So now that we have our stated givens, and again, I'm not going to write down the sample size, but I am going to just kind of let you know that's what it is because we're solving for both at the same time. My next suggestion would be to draw it out. So we're going to draw both of them. First one, second one. And then they said it was normally distributed. Normally distributed. So for the first one, and then for both, of course, the mean is 63. Mean is 63. And then for one, we got 62. Okay. So for one, every time we look up a z-score or go to the z-table chart or whenever we calculate it, it's going to give us that score less than that actual score. So that means it's always going to give us the area to the left. So we're going to put G for given here, and we're going to put G for given here, because this is what the score is actually going to give us. Now, based on what we're looking at, this one is saying it wants the probability that's going to be less than 62. So if it's less than, that means that we're also looking, or we also need the area to the left here. So for this one, the need is less than, but for this one, it's greater than. So we need the area to the right here. Now, under normal distribution, this is conceptual, and we'll just put it in here for need. So we know here we'll be doing 1 minus that. Okay, so in order to get the score here, because under normal distribution curve, it is worth 1. So now we're going to actually calculate for our z-score. Do it twice. Okay, so now we have everything that's written out for us. So we know that the mean is 63. The score for here is going to be 62. So we're just going to edit the equation. And we essentially know that x is 62 minus 63 divided by 2.5 divided by the square root of 36. Okay. That's how we work out the first one. And the second one, we're going to do the exact same thing, but we're just going to add in the relevant information. So we're going to do 62.5 minus 63 divided by 2.5 divided by the square root of 70. Okay. After that, we're going to actually calculate it to give us our z-score. So 62 minus 63 divided by 2.5 divided by the square root of 36 equals negative 2.4. Okay. And then 62.5 minus 63 divided by 2.5 divided by the square root of 70 gives us a negative 1.67. Okay, perfect. So now that we actually have the z-score, you're going to need to actually figure out what the probability is, right? So my recommendation, you can either use, if you have a TI-84, you can do that, or you can go to Excel and you're going to do the norm function. You're going to do norm S dist, and then you're going to put negative 2.4 for the first one. And that gives us a nice figure, depending on how many area places they tell you to round it to. Usually they'll tell you to do 4. So this would be about 0.0082. Okay. And then the other one, you're going to do that again. As opposed to negative 2.4, we're just going to put negative 1.67. And that gives us 0.0475. Now, in this one, we already said, because we drew it out, that we are not done. Okay, so I can stop sharing this. Equals 0.0475. We did say that we're going to have to subtract it from 1, because this is not what we essentially are looking for. This is the area that's lower than. Okay. And that's just not what we need. So in order to get the other way, we're going to have to subtract. So the probability of it being less than that is going to be 1 minus the probability of x being less than 62.5. Which in this case is 1 minus 0.0475. 0.0475. And if we subtract that together, that essentially gives us 0.9525. Okay, so to bring it all together to answer your questions, what is the probability that the mean height is less than 62? The probability is 0.0082 or 0.82%, depending on how they want you to actually report that. And then the probability that the mean height is greater than 62.5 is roughly about 95.25%. Square our answers to show our work. And that's it. I hope you found this video to be helpful. If you have any additional questions, please let me know.